Hello and welcome everyone. We're going to be looking at the 2.1 Peardeck because we have officially finished our Module 1 and we're moving on to Module 2, which is really exciting. So go ahead and open up that link, throw your name on that top line, and then you can put today's date as well. And when you're all set, take that and push ahead to slide 2. In slide 2, we're learning that we're going to start talking about relations, functions, domain, range, all of these vocabulary words that you have been starting to learn when you were in middle school, and now we're bringing it back and kind of leveling up a little bit. So the first definition word that we're going to fill up at the top is the domain is our input values. These are our X variables. Input, domain, X, those are all saying the same thing. And underneath that is our range. The range is our outputs. It is our Y values. Those all mean the same exact thing. The input or the X values are called the independent variable. And we see that variable along the X axis, right? If we're drawing a graph, our X axis is horizontal and our Y axis goes vertical. Our Y axis is the dependent variable because our Y value or our output depends on what the input was, right? If the input is 2, then we can figure out what the output is. We need to know the input to figure out the output. And then finally, our last vocabulary word here is a function, is a mapping between two sets where each input or each X has only exactly one output, and that makes a function. So here's just a little information to get us started about domain, range, input, and output. Feel free to pause the video whenever you need at any point, and when you're all set, push ahead to slide 3. So we're going to talk about all the different types of ways that we can show a relation or a function. And 2 of those types down here are below. We have a mapping. That is this type in red. This here is our mapping. And then next to that is a table. Okay, so these are 2 types of ways that we can show what a relation or a function is, using a map or using a table. The domain contains the input values. So looking at these 2 different ways to represent a relation, the domain is our X's. So here's our input values. We have an M, we have an N, and we have a -2. So I would just write that as, in curly brackets, M, N, and -2. That's our domain. Those are the inputs. The range is the output values, which we have 8, 5, A, and B. That is our range. So we can see in our mapping down below that M maps to 8. So, right, this is a coordinate. Oops. This coordinate is M, 8. N maps to 5. So there's our next coordinate, N, 5. And then negative 2 maps to two numbers. It maps to an A and it maps to a B. So this is not a function because negative 2 has two different outputs. And that's bad. It's still a relation, but it's not a function. Okay? Because if we input a negative 2, we don't know if we're going to get an A or a B out. And with a function, you have to feel confident that you know you're going to get either, that you know you're going to get that output value. And we'll look at more examples of this as we continue. But when you have everything you need here on this screen, push ahead to slide 4. So thinking about functions, domain, and range. Looking at these, circle the relations that are functions. So for the first one, our domain is 4 and 3. Those are the inputs, right? They're on the left side in the X area, and the range is 3. There's only one number from the range because 4 maps to 3 and 3 maps to 3. But this is okay. They can have the same output. Two different inputs can have the same output. So if you go to like a vending machine and you hit the number 4, you're going to get out a 3. Or if you hit the number 3, you're going to get out a 3. That's okay. What we don't want is if you hit the number 4 and you don't know what you're going to get because there's two different options. For example, with the table in the next one, there are two options here. If you hit number 5 for your input, we don't know if you're going to get out a 3 or a 4. So this is not a function. It's a relation. We still have a domain of 7 and 5. And we have a range of 3 and 4. But it's not a function because each input does not have its own output. Okay. For the next one, for 3, this one is a function. There's no x values that are on top of each other. Each x value is in its own vertical place. So some x values we see here are negative 2, negative 1, 0, 1, 2, and 3. And those are all the x coordinates of these points. And the range goes from negative 2 to 0 to 1 and to 3. Those are all the y values. So don't worry if you're not sure how we're getting these yet necessarily. We're going to be doing a bunch of practice with this, so don't worry too much. And this one, for the last one, is not a function as well. Because if we draw a vertical line, these 2 points have the same x, but they don't have the same y. So that's bad. Those are not a function. Okay. So just getting a little introduction to it. But no matter where you're feeling, we're going to go through and do a bunch of problems now as we move through this lesson. So push ahead to slide 5 when you're ready. Okay, let's plug some vocabulary in. Really important to drill this vocabulary. So a relation is a set of ordered pairs. That's a relation. There's some relation between the x's and the y's. We have these ordered pairs. Now, a specific type of relation is a function. And this is where every input, which we remember, input is our x, is mapped to exactly one output, y. The domain of a function is the set of the input values, and the range is the set of the output values. A continuous function has no breaks and no gaps, and a discrete function is a set of points. So when you're thinking about a discrete function, we might have a graph like this, And if it was discrete, it would just have points like this. There's no line connecting them, but it's just discrete points. Versus a continuous function has flow, right? Maybe there's flow, like something like this. There's no holes, there's no gaps, it's just this line of flow. Okay. When you're all set here, go ahead and push ahead to slide 6. So we're going to dig deeper into what does this mean to be a function, domain, range, exactly one. There's a lot of new words being thrown at us. So let's break it down. A relation, so this is the definition of function. A relation between two sets of values when the inputs, one the inputs and the other the outputs, such that for every input there is a unique output, right? So if we put something in to the function rule, like 2x plus 3 or 5 times x, whatever the rule is, we know what our output is going to be, and there's one output. We plug in an x, it multiplies, adds, subtracts, it does those operations, and we get out a y. There's this flow that we have here with a function, right? We know we'll plug something in, we'll get one specific answer out. That is the magic of a function. Okay. I love to think of vending machines. Like, I know if I plug in 2A, I know what I'm going to get out, right? It's not like this mystery or where there's multiple options under 2A. We know what our output is going to be because it's going through that machine and getting that rule. These are the 4 ways on slide 7 that we represent relations and functions. So the first in the top left, we saw some of this. This is called a mapping. This is a map. We have our inputs on the left, outputs on the y. Next to that, we have a graph. Down below, we have an equation. And finally, we have a table. So these are the 4 ways that we can represent a relation or a function. So we're going to get really comfortable identifying and reviewing and working through these 4 different types of relations and functions. Slide 8. So again, here's an example of a relation and the 4 different ways that we're representing it. So you could think of this relation of ordered pairs. There's 4 points. Great. We can put those 4 points in a table. Here's our x values, 2, 1, 1, and 0. And our y values, -1, -2, 3, and 2. We could also take these points and put them on a graph. And that's another way to represent the relation. And finally, we could take it by mapping, right? 2 goes to -1, 1 goes to 2 and to 3, and 0 goes to 2. So a function is a relation in which each element in the domain matches exactly one element in the range, which means this is not a function because we have 1, -2 and 1, 3. Now that's a problem because if we plug in a 1, we don't know if we're getting out a -2 or a 3. So it's not a function. It didn't follow a rule to give us one specific output. Here's another visual. We have an input, we have a function rule, and then our output. And domain is our input, range is our output. So these are just visuals to show you and to help our brains understand what's happening here with relations and functions. Push ahead to slide 9. So I think, okay, yeah, so slide 9 on the left, we have graphs. I'm going to pause it here actually, and we'll pick up on slide 9 in part 2 of the video. So meet me there.